Bismillahirrahmanirrahim. Assalamu alaikum. This is Dr. Nosheen Tariq Siddiqui. We were doing pharmacognosy course number 418. We have already gone through our first topic, which was drug of animal origin, in which we have studied that those drugs which belong to animal origin in particular, and we have gone through their uses and how they are formed in animals. The next topic of our interest is biologics. What are basically biologics? These are the products which are derived from living organisms and which are used for numerous purposes or numerous therapeutic reasons in our body. For the detailed definition, we can say that the biological products means a virus, therapeutic serum, toxin, antitoxin, vaccine, blood component, or derivative, allergenic product, protein, except any chemically synthesized polypeptide or analogous product, or arsenic or derivative of arsenic or any other trivalent organic arsenic compounds applicable to the prevention, treatment, or cure of a disease or condition of human beings. These biologic or the biological products, these are used for the prevention, treatment, and cure of disease. They can be used for either of them, either prevention or for the treatment or for the proper cure of the disease or a condition in human beings. This arsenic, which is written, this is used in the treatment of cancer. So these type of products like vaccines and the blood products here, or the blood components, serum, toxins, these all are termed or named under biological products, and they are known as biologics. Biologics generally divided into two types. They are basically of two types, but there are other types of biologics which are now people are researching or scientists are finding. So, but right now we are mainly concerned with these two types. What are those? These are antigens and antibodies. Antigens, what are antigens? Antigens are agents which provoke immune system, which basically when entered into your body, they provoke your immune system, and after provoking an immune system, what it does, basically the formation of antibodies starts. So we are also concerned with antibodies. So biological generally divided into two types, antigens and antibodies, which antibodies causes formation of antibodies. Antigen are of three types. These are biological antigens. Certain times we have chemical antigens and physical factors which act as antigens. Antigens possess two biological properties. What an antigen should have? It should have immunogenicity, means power of producing immunity, and specificity, means for what certain type, it should have a specific type of activity related to the formation of antibodies. Basically, chemically, they are basically they are also carbohydrates and they are also protein. Okay, in carbohydrate they are usually of polysaccharides, while physically they are of high molecular weight compounds. Okay, so what is immunity? You are going through, I think, in your biology lectures or microbiology class, of course, you are already going through immunization or immunology as a whole. Here in pharmacognosy, I will discuss this not in very detail, but I will give you a brief account what is immunity and what type of immunity there are. So immunity are of two types. Immunity is basically what? The fighting against diseases is basically immunity of a body. So there are two types: natural, which is also known as innate, and acquired. Natural is body's natural mechanism to fight against the different bacteria which are entering into the body. And we all know that in in normal condition, we are bombarded. We should say that we are bombarded because there are thousands and there are numerous and there are countless bacteria which are surrounding us and which are constantly coming in contact, with which we are constantly coming in contact. But our body is able to, they are not producing any effects or disease because our body combating it by itself, by the immunity Allah has given to us, or our body is born with that immunity or that strength to overcome those numerous bacteria or viruses which are coming, which are surrounding us. So we all have certain type of natural or innate immunity, which gets weakened with time. In children, the immunity is quite well, and but later when the health deteriorates, so our natural immunity also weakens up. And certain times the bacteria are so powerful that even the children got certain type of bacteria, certain type of diseases. So for that, we give vaccines to enhance or to make our immunity system better. So there are two types. One is natural, the one we are born with, and acquired. Acquired means which we are getting from outside of our body. But this again are of two types. Active is that immunity which is naturally acquired and artificially acquired. The detail I'll show you in the next slide. The acquired immunity is of two types again, active and passive. Active is again naturally acquired and artificially acquired, while passive is also natural and artificially acquired. What is active immunity? Specific immunity develops by an individual in response to the introduction of antigenic substance in the body. This is a specific immunity which is developed by a person in response to what? When he or she is being introduced by any antigenic substance in the body. It includes natural infection. If you get a natural infection, then your body starts combating with that infection, and it develops immunity against that infection. Vaccines are also among the immunity, which is comes under active immunity. There are certain toxoids. Toxoids are compounds which are produced by different bacteria, and they are relatively permanent. Immunity, which is passive, means immunity produced as the response of a series of injection. It basically forms, or it produced by a series of reaction, includes natural material antibodies. Certain times, in passive immunity, ready-made antibodies are injected. Antitoxins comes under this, and immunoglobulins are the types of passive immunity. So what is the difference between active and passive immunity? It is in active immunity, it is developed due to the contact with pathogen or its antigen. It is developed by the direct contact with the pathogen or its antigen. While passive immunity, it is developed when ready-made antibodies are injected into the body. These antibodies are produced or formed outside of your body, and they are injecting into your body directly. So that is passive immunity, means your body is actually doing no work or don't have to do much work in passive immunity. In active immunity, it has no side effect usually because the body itself is making the good material. So the body is not making any harmful effect, harmful material, so it does not have any harmful effect. And passive immunity, it may cause allergic reactions, which happens in many cases while you give vaccine or anything which concerns with passive immunity. So it may cause allergic reactions. It is slow but long lasting, which active immunity is very slow, but it's long lasting. Certain times it is so long lasting that it can encompass a person's whole life. Means that a person can be saved from a certain disease throughout his life. While the passive immunity, it is fast but lasts only for few days, and you need a booster or you need a certain type of dose again and again for that. So in active immunity, it takes time to develop its response. In active immunity, it takes time to develop response because the body itself is making that response. While in passive, it provides immunity immediately. And when you require an immediate response, your preference will be passive immunity. For example, of active immunity, vaccination for polio, etc., are the active immunity, while for the passive immunity, the administration of tetanus serum or the ATS is passive immunity. Okay, now the types of vaccines. We have different types of vaccines in which we have live or attenuated vaccines, like the oral polio vaccine, killed vaccines, like the typhoid vaccines. Example, toxoids are tetanus toxoid is an example. Prepared antibodies means the ATS, that is anti-tetanus serum and anti-venom. We also have a new kind of vaccines like second generation vaccines. Hepatitis B vaccines are the second generation vaccines. And we have, this is the recombinant technology basically. What is that? I'll discuss in later slides. So how the vaccines are formed, how they're synthesized. Certain time the pathogen, you get the pathogen and you attenuate it, or you basically reduce its virulence. The ability to cause the effect, you basically reduce that virulence, and this is called the attenuated pathogen. While certain times you basically kill that pathogen by providing heat or UV radiation, and then you inject to the body. So this is another type, that is killed pathogen, and certain times attenuated. Certain times what you do, you take a toxin and you remove the harmful components of the toxin. After removing the harmful component of your toxin, you get a toxoid. Toxoid is basically, it is devoid of the harmful effect, but it still gets its antigenic properties. Okay, how the synthesis is vaccines are prepared, or ATS in particular, in the formation of ATS, what you do, you take tetanus toxoid and you inject it in a horse. In horse, the toxoids, they multiply, and the serum, it develops the antitoxin, and then you take out that serum, and that serum is injected in the patient of tetanus. That's how the patient is protected. What is the difference between tetanus toxoid and anti-tetanus serum? Tetanus toxoid is basically an active vaccination, while the anti-tetanus serum is the passive vaccination. Tetanus toxoid is given, antibodies will be formed in the body of a person. So you give tetanus toxoid before it's given from, when a person don't have tetanus, they have not developed that condition of tetanus. So you just give it in a precautionary basis. So if injury occurs, so you give it in a precautionary basis. But if a person starts suffering from tetanus, so you for its life saving, you give anti-tetanus serum. Okay, what is the procedure of the synthesis of vaccines, the second generation vaccines? You take out actually, when the hepatitis vaccines were B vaccines were first prepared, they were prepared from the serum of the infected people. But they were not used, or there were chances of getting HIV infected blood as well. So the use of taking out the serum from the infected blood was was discontinued, and then a new technology was developed. What was that technology? That you get the DNA strand, and you basically the start culturing the bacterium or the hepatitis B virus, and there is a technology which is known as recombinant DNA technology. In that, you basically what you do, you within an enzyme, there are two enzymes. One enzyme which breaks that DNA from a certain point, and after breaking that point, you introduce the another DNA, the plasmid DNA, and you make you again first you break, and then you rearrange or remake that DNA by applying one more enzyme, with which now the DNA, which is now in combination with the plasmid DNA of the bacterium, you basically grow it in a medium which is yeast cell, and then you ferment it and produce more HB antigens. And after extracting out those antigens, you make a vaccine, basically. Okay. So what is a vaccine? Vaccine, the term vaccine derives from Edward Jenner's 1796 use of the term cowpox, variola vaccinae, adapted from the Latin vaccinus from vacca cow, which when administered to human provided them protection against smallpox. Basically, this Edward Jenner, his son was ill with smallpox. What he did was that he take out a pus from infected cow and introduce that pus in his own boy. Okay, and he inferred that it created immunity in his son. So the modern science of immunology had its beginning in 1798 when the English physician Edward Jenner published a paper in which he maintained that people could be protected from the deadly disease smallpox by the prick of a needle dipped in the pus from a cowpox boil. When he basically had this vaccine type of thing from the pus of the cowpox boil, and he injected that into a person who is suffering from smallpox, like his own son. Basically, this process of injecting pus into the body, it was not basically only and solely devised or discovered by Edward Jenner, but there is a paper, there are research papers, which says that it was basically used by Muslims first, but they didn't actually, they didn't had a paper, or there's nothing like that. So people thought that it's only Edward Jenner's thinking, but Muslim scientists used to perform this type of procedures as well. What are the classification of common vaccines for humans? Whole organisms. What type of disease and for what type of vaccine is used against that disease. Whole organisms are used for bacterial cells, anthrax, against anthrax, cholera, pertussis, plague, tuberculosis, and typhoid. Uh, Whole organisms are used, and I think now for corona as well, whole organisms. In there are different types of vaccines. We can discuss in our later class that what type of vaccines are there present and what technology have been used to make those vaccines. But right now, let's see what type of vaccines are used for anthrax. It's an inactivated. For cholera, inactivated whole organism, pertussis, and plague. The whole organism, which is an inactivated, is used, while for tuberculosis and typhoid, it's live attenuated. They have both. Live and attenuated means they are devoid of virulence. Basically, they cannot perform their action. And what type of viral practices? Hepatitis A, influenza, measles, polio, rabies, rotavirus, varicella zoster, and yellow fever. Why it is written polio sabin and polio sag? Because there are two types. In polio sabin, it has live and attenuated, while in polio sag, it is inactivated form of the polio virus. Okay, there are different types of viral vaccines. I think it should be included corona vaccine, but I'll take it as a separate topic. Okay, I'll discuss the corona vaccine in a separate topic. Right now, we'll see what are the type of viral vaccines. There are mumps, rubella, smallpox, yellow fever, and influenza. Measles, what type of viral vaccines measles are? They are live attenuated virus grown in chick embryo fibroblast, first introduced in 1960. Its extensive use has led to the virtual eradication of measles in the first world. Means there are very less, maybe there are, but basically you can say it's the virtual eradication. There, people don't have measles over there. In developed countries, the vaccine is administered to all children in second year of life. However, in developing countries where measles is still widespread, children tend to become infected early, which frequently results in severe disease. And it is therefore important to administer the vaccine as early as possible, between 6 months and a year. If the vaccine is administered too early, however, there is a poor take rate due to the interference by maternal antibodies. For this reason, when vaccine is administered before the age of 1 year, a booster dose is recommended at 15 months. You see, in developed countries, this vaccine is developed to the children in the second year of life. But in underdeveloped countries, in developing countries like us, we give this a vaccine between six and a year, in between 6 months and a year. So why? Because here it's still very widespread. So for the protection of children, we give them between 6 months to a year. But as there are antibodies by the maternal, there are some antibodies given to the child through milk or through mother. So for this reason, it interfere with the antibodies formed by the vaccine. So that's why a booster is given at the age of 15 months, which is then it is sufficient for his whole life, the rest of his life, to be able to protected from the disease like measles. Okay. Mumps, for mumps, we have live attenuated viruses developed in 1960. In first world countries, it is administered together with measles and rubella at 15 months in MMR vaccine. The current virulent strain of the mumps vaccine was developed by Dr. Maurice Hillman from the mumps virus that infected his 5-year-old daughter. This vaccine, combined with rubella or both rubella and measles vaccine, has been widely used worldwide, about 300 million doses given since it was approved by FDA in 1967. Polio, two highly effective vaccines containing all three strains of polio viruses are in general use. The kill virus vaccine, the live attenuated or polio vaccines. The kill virus vaccine, which is also known as SOG in 1954, is used mainly in Sweden, Finland, Holland, and Iceland, while the live attenuated or oral polio vaccine has been adopted in most parts of the world. Its chief advantages being low cost, the fact that it induces mucosal immunity, and the possibility that in purely immunized country, vaccine strains might replace circulating wild strains and improve herd immunity. You know, this herd immunity, this term is very important because, you know, and in case of corona vaccine, you know, why we are giving to all of the people, or we are trying to give it to all of the people, because we are trying to improve the herd immunity, or to enhance, or to make a herd immunity. You know, herd immunity is very important because when all of the people are, you know, with which the organism is coming in contact with is immunized by the disease. So the it's a hypothesis that the virus gets, you know, weakened, and with time, when it does not, because if virus need a carrier, when it does not get a carrier, you know, it completely eradicates. That's how, you know, people in there are many diseases which are totally eradicated now, because we have created a herd immunity. So it is very important that everyone gets that vaccine, so we improve the herd immunity and we overcome the disease, or the disease will die out. Rubella, it's live attenuated virus. Rubella causes a mild febrile illness in children, but if infection occurs during pregnancy, the fetus may develop severe congenital abnormalities. Two vaccination policies have been adopted in first world. In the USA, the vaccine is administered to all children in the second year of life in an attempt to eradicate infection, while in Britain, until recently, only post-pubertal girls were vaccinated. Why? Because they develop fetal congenital abnormalities, because it has infection which can occur during pregnancies and which can be fatal for the fetus. So it was developed, or it is given in the second year of life. It was feared that if the prevalence of rubella in community fell, then infection in the unimmunized mite can occur later, thus increasing the likelihood of infection occurring in the childbearing years. This program has since been abandoned in Britain, and immunization of all children is the current practice. But now the immunization in the children is currently in practice. MMR, that is live measles virus, live mumps virus, live rubella virus. This develops in chick embryo and it's given. Okay, we'll do the rest in our next slide.